Good morning, Namaskar. This is Engineer Suraj Singh. In continuation to my previous curing talks, I just want now to talk about curing for those members which are not ordinary ones. Like I said, those members are defined as thick members and mass members, mass concrete members. Thick member in the sense, I think you know, any member which has dimensions more than 80 centimeter or 800 mm and volume of concrete is up to 8 cubic meters. We can call it thick concrete member, while the other one where dimension is say more than 0.8 meters and volume is more than 8 cubic meters, we can call that mass concrete member or massive block. The difference in this curing approach is that we should not do the curing as we did for ordinary members, as I discussed before, for these slabs, for columns, for beams, for graded slabs, because those members are not thick. Those are thin members. The volume is more than 8 cubic meters, but sections are less than 0.8 meters. Those can be applied with water curing or with curing compound. That is called water-based curing. But for thick members and mass concrete members or massive concrete members, the approach should be changed. Exclusively water-based curing is not very successful for those members. There's another term that is called thermal curing. The difference between the thermal curing and water curing is water is applied in that curing for the purpose of replenishing the loss of water by evaporation from the concrete. But in this case of thick member and massive concrete members, the curing is reverse process in which water evaporation is not allowed. Water is forced to stay within the concrete and curing is done by that water itself. No further allowance of water on that, no exposure to weather. Let us say foundations of machines, for example tabletops, there are heavy columns on that. Dimensions of those columns is always more than 80 centimeter or 1 meter and cubic content is up to 8. And also for the foundations of those members, say tabletops and massive blocks in the foundations of compressor foundations or generator foundations, that member requires thermal curing. Let us say foundation of a tabletop, which is some around more than hundreds of cubic meters. For example, crack gas compressor. I did a foundation that was having 400 cubic meters concrete, isolated one, with massive quantity and dimensions more than around 2 meters depth, 25 meters length, and say 12 meters width. What we did after pouring the concrete, just the surface was covered with polythene immediately, and then clean sand was filled on that temporarily. It was covered. There was no allowance of evaporation, and it was kept there for a period of 7 days. And the sides were kept there, shutters were kept there. The shutters were not allowed to be taken out, and these were kept in moist conditions, either by spraying of water on those shutters or by wrapping by any means, so that temperature is maintained. The point is, for the construction of a pouring of concrete for these members, temperature remains in the range of 20 to 24 degrees, while for general concrete, or for normal concrete, it remains 32 degrees or more than that. This is very important to maintain the low temperature within the concrete, and in certain cases, we have to make sure that the temperature within the concrete remains in that limit. And for that, we use sometimes rise and fall temperatures, thermometers, rising and falling thermometers at various locations, so the gradient of thermal flow is recorded This is very important issue for curing because generally we use either GGBS or micro silica based concrete for these members, and all these are meant for low temperature behavior. The same thing applies for thick members, which are columns, for example, big columns. After doing the concrete, we should not remove the shutters within 36 hours or 48 hours if it is permitted by the site requirements. If you have to repeat, it is something else. If we can absorb non-repetition, we can let these columns to stay there for say 7 days, 8 days and cover the top portion and just maintain the temperatures on surfaces or on the temperature outside the shutters. Keep the top portions or top of columns closed and let it stay there for 7 days or 8 days. There is no requirement of further addition of water on that member, and that process can be virtually called thermal curing. It's not available in text. It's a practical learning. I was given this long back and I was confused, but when I did practically, the results were acceptable, and this generally is a specification on onshore or offshore projects. Curing is very important, as all of you know, and we have to achieve this activity very well. There should be no ignorance on anybody's part for this curing. Curing, though it is very easy, and some of my friends said this curing is easy and this is difficult. I know this is all superficial understanding of curing. All curings are difficult. Curing is the life of concrete. Without curing, tube fails, and without curing, cores fail, and without curing, concrete fails. And if concrete fails, all efforts go wasted. It's very careful requirement for any foreman, engineer, or manager to make sure that curing is done very well. It's achieved very well. Otherwise, it's a big loss to everybody. So today I just wanted to explain about thermal curing. There's also another process called steam curing, which is generally called autoclaving of concrete. Steam curing is done for after 12 hours and shutters can be removed, but that is another talk. I like to close today's discussion for the sake of time limit, and dear all, thank you very much for giving your attention and regards. This is Suraj Singh. Bye.